Angle measures and segment length.
I am very special female.
Hey, hit me up with one. Okay.
Are you kidding, Sam?
All right, so we have another new little piece to describe secant. S-E-C-A-N-T. A secant is a line that intersects a circle at 2 points, as opposed to a tangent which intersects a circle in 1 point. Secant. And yes, there is a chord contained by the circle, but the line itself is a secant. Okay. If the secant went through the center, it would contain a diameter. Okay, there'd be a diameter as part of it, but diameter is a segment, a chord is a segment, a secant is a line. The first theorems we're going to deal with are specifically for angle measures. Okay.
I'm doing my arthritis in my wrists, my knuckles, and my neck.
All right, so the first theorem has an inside intersection. It's important that you know the difference because there's one theorem that we get to add, one we get to subtract. Inside intersection is the only one you will be adding. So we're going to describe how to find angle 1, which is the same as the vertical angle, so it doesn't really matter which of these you're talking about. What does matter is the arcs that we use to find that. So this arc here we're going to call X, and this arc here we're going to call Y. And if you put some chords in and use some inscribed angles, there is a proof of why this works, because it has to do with the angle being half of the arc and adding a few things and triangles adding up to 180. You don't have to do that. They are giving you nice little compact formula which says the measure of angle 1 is half of the sum of the two arcs that those angles open up and create. Okay? If I were talking about the other two angles, I'd have to use the other pair of arcs. Okay, and that's for an intersection we get to add. The outside intersection is going to be subtraction, but we've got kind of 3 possibilities here. They're all similar, but slight difference, yes.
So wouldn't measure 1 just be half of the arc triangle? Can't you just do that instead of...
No, you have to add them together.
Oh.
It's half of the sum.
Oh.
This is not a central angle. It's not, it does not have a vertex at the center. It's not an inscribed angle. It doesn't have a vertex on the side of the circle. Okay, this is not a central angle, not an inscribed angle. It's an intersection of 2 secants that does not go through the center. Okay? Thank you for asking. That helps me to clarify. Okay. Now, these diagrams have an outside intersection. Okay, these are still secants. The first one would be, oops, let me get that up a little bit. Okay, first one would look like that. 2 secants. The second one would be a secant and a tangent. And the third one would actually be two tangents. And each time we're talking about that outside angle. It's what we'd be trying to find, or maybe we have that and we're trying to find an arc measure. Okay, they are related. But here's where we're going to specify. These arcs are very clearly defined. This is X. That's Y. Here, remember, a tangent only touches in one place. So from the point of tangency to the other intersection, that's X. From the point of tangency over to the secant on this side would be Y. Okay. In some of your problems, you might be missing one of the arcs, but maybe have this one instead. But that's, as long as you have 2 out of 3 of these arcs, you can subtract from 360 to find the one that you are missing to set up the formula. This one, from the point of tangency all the way around to the other point, is X, and Y for 2 tangents is the rest of the circle. Not half. No. Unless the point of tangency is diameter to diameter. Okay. Because the smaller that gets, your point of tangency moves closer together. You know what I mean? So it's not, but what you may be talking about is I would not use the formula to find one of these arcs. I would only use it for the angle. If I had one arc and not the other, I wouldn't use the formula, because if I had one and not the other, I would just subtract from 360. It's kind of silly to use a formula that involves a couple steps to find an arc that's the remainder of the circle. So you would only use this one to find the angle. Okay? But what the formula is, it goes with all 3 of these. Okay, again, the inside intersection is addition. The outside intersection is the same, but it's subtraction. So the measure of angle 1 is 1/2 the difference. And you want to do the larger arc minus the smaller. Because if you switch them, you're going to get a negative result, which would be a negative angle measure. And that wouldn't make a whole lot of sense. Okay, so formula is the same, it's just outside intersection is subtraction. So we're going to do a couple examples for this one. So these give a good variety. Okay, this is the only one that has an inside intersection, so this one's addition. So the angle would be half of the sum of the arcs. And keep in mind, they could give you, you know, these 3 arcs and not one of them that you need, but your entire circle should add up to 360. So this would be half of 136, or 68 degrees. The rest are subtraction, but you always start with the angle. So here we have 20 equals 1/2 of the difference of the larger arc minus the smaller. And unless you want to distribute the half and deal with that, since this is multiplication, I would just suggest getting rid of the half. And how do I do that?
Divide.
Multiply both sides by 2. Okay, so on the left we have 40. The 2 and the half cancel out, so then we have 95 minus z. Subtract 95, so we have negative 55 equals negative z. But you don't want negative z, we want z.
Wouldn't that just be 55?
Yep. So z equals 55 degrees.
What'd you do Z for?
I don't know, I think that's what they had. All right, so these two are the same formulas, starting with the angle. Y equals 1/2 of the difference, 250 minus 110. So you're actually going to subtract 110 from 250, so that would be half of 140, which is 70 degrees. So what would my setup for the last one be? Yeah, so half of the larger arc minus the smaller, so that would be half of 80 or 40.